scores. Example, we will take the standard scores for the height, the previous example. For a population of college women, the z-score corresponding to a height of 62 inches is, we can use it like this. If we go back to the previous example, and we know that the value is 62, as we see here from this example, 62 inches, okay? And we know the mean of the whole population is 65. With a standard deviation of 2.5, we can apply the equation, which is z equal to value minus mu divided by the standard deviation. Now, 62 minus 65 or 2.5, it will yield minus 1.11. So this is the main z, the z value. So the z-score tells us that 62 inches is 1.11 standard deviation below the mean height for this population. This is how can we convert it to the z value. The z-score from minus 1.11, it means that 62 inches, as we take from the example above here, 62 inches is 1.11 standard deviation below the mean height for this population. That means that we are moving, if we have a standard normal curve, we are moving just only 1.11 standard deviation units below or above, okay, the standard normal curve, or the mean actually. Because it is a value of minus, okay, it's a negative value, it's below the mean. So it's below the mean because 62, as you see here from 62, is lower than 65. But we convert it to what? To standard units. Okay? So now we'll go directly. How can we use the z table? Finding probabilities for the z tables or the z scores. Remember that the z scores is there in the textbook that has been uploaded in the e-learning system. You can take it from the book, okay, and see the probabilities. Finding the probability for z values, table of z, it is a standard normal z probabilities. You can see here the z value, and also we have rows and the columns. Body of the table contains, if you go to the table, and you do need to have the table with you always, body of the table is the probability, contains the probability of z less than or equal to z star. Leftmost column of the table shows algebraic sign, as you see, digits for the chemical or decimal place, and the third decimal place for z star. Second decimal places of z is in column heading, as you see from the column heading. More finding probabilities. If we are interested, for example, to see the probability of z less than or equal to minus 3, we will go directly to the table. Okay, see the 3. Okay, as you see here, and we have minus 3. We will go to the minus 3 right directly from the table, and we don't have any value. It is a 3.0. Okay, 3.0, you can see this is the lowest value in the table, and you can see whole table from the textbook, or you can Google it and take it in a PDF form. Okay, so minus 3 here is equal to 0.0013, directly taken from where? From the table. Those are the z value. Now if we take the probability of z less than or equal to minus 2.59, you can go directly and take it from the table. It will be like this, okay, 0.0048, 0.0048. Here we don't have the probability of minus 3, but if you go to the table, you can see it directly like this one, and you can move from the z values. Like, for example, if you have a 3.01, the 3.01, it will be 0.0013. And also if you have 3.03, you can go with the column, cross tabbing with the 0.03 in the rows, okay, and you can see it's 0.0012. and so on. You can take all those values directly from the table, but you do need to characterize or to calculate the z value by using the equation that has been the value minus the mean over the standard deviation, and you will take the probability, direct probability from the table. Now, as you see, another example, probability of being x more than 1.31, more than 1.31, and remember the last equations or the previous lecture when we are talking about the cumulative frequency, and I told you that we are dealing with cumulative. It is a complementary, okay, okay. So all the total area is 1, but if we want to take larger than or greater than 1.3, okay, it means that we are dealing with all numbers that are above 1.31. So we will take 1 minus the probability of being less than or equal to 1.31. So from the table directly, you can take the probability of being z less than or equal to 1.31 and subtract it from 1. It will yield this value, and we can draw this value by using this normal curve. This is the density table, okay, and this is the scores, the z scores. The z scores 1.31. What does it mean? As we see from the height, from there, the height example, we are covering this shadow. We are covering this shadow area. We are dealing with this one because all the area below the curve equal to 1. It means 1 minus 0.9049. 0.9049, we take it directly from the C table. You will take it from the table that it's located in the textbook. Okay, I think it's A2 table. Okay, and the standard area is 0.0951. This is the shadow area. We are looking for the shadow area. But if we are interested in the P more than or less than or equal to 1.31, it means that we are dealing with this white area, all the area below the shaded area, not included here. Okay, this is how can we cover the z values and the t values from the by using the equation, and also by using the standard z table. Okay, another example, what's the probability of z to being between minus 2.59 and 1.31? What's the probability of obtaining z to be larger or greater than or equal to minus 2.52 or 59, or lower than or equal to 1.31? Now we'll go directly to the table. We will take from the table the probability of being z is less than or equal to 1.31. Okay, less than or equal, okay, to 1.31, subtracted from being the probability of z less than or equal minus 2.59. So those values 0.9049 and minus 0.0048, we take it directly from the table. Now, if we want to draw the curve, we are dealing with 1.31 here and minus 2.59. So this is the shaded area that we are interested in. This is the shaded area, and the total area is 0.9001. That is the probability of being z between minus 2.59 and 1.3. So the probability of obtaining z is about 90%. This is how can we deal directly with the table, the z tables, that you should take it from the table, or you can Google it.